About the direct addressing nodes, sir, and cache memory nodes, sir.
Addressing no modes, I think I have given, na? Only the cache
No,
memory
sir,
is not.
last day in the group, the one you gave was the notes for this clock cycles and CPI, those performance problems, sir. You gave us the performance problems that you had discussed in class, sir. So not the addressing, not the direct addressing mode and
So we didn't get the notes of memory management.
yes, sir.
Now,
Yes.
management note yet I have not circulated. Just after today or maybe tomorrow, after finishing the chapter, I will circulate to you.
Okay,
Yes,
sir.
sir.
Video lectures also, sir.
Which one?
8th February video lecture.
8th February video lecture. Is not within me or within the students, I think.
Sir, if you record, only you can share it with us, sir.
Yeah, now I will share. No problem. But that 2 days, I think I have not recorded. Na? Today I am
8th
start
February
recording.
You recorded, sir.
Since today I am recording, I will give you the recorded you. Okay. Now start one. This is the last class regarding the direct memory. Okay. To understand it, I would like to highlight that. Suppose these are all the different cache line. Okay. So this is the cache lines, and if I choose here, suppose 00 I have chosen. Okay, I have chosen 00, then automatically all the 0 line will be selected. Okay, 0 that means connected with the, if I right click in this way. So you will find that though I have mentioned here this part is will come here, this part is, if I write in this way, actually this is the MSB. So I am considering this is the MSB part and this is the LSB. Last so it is the LSB. Like in this way, I have considered the bitwise orientation. So this MSB will be connected to this one. This again, the MSB of this one also connected to this one. And MSB of this part is connected this one. MSB of the part is all connected this one. Since you have selected 00, I think this will be selected that way for this node. And this is the my cache line 00 also. Okay, if I write in this way, suppose the cache line. Now in these cases, 00 means again this will be selected and this will be nothing but the middle bit of this one. So again it will be selected. So you notice there the tag of the 00 is automatically selected by this application of multiplexer. Is this now correct with this figure? Now you understood that. Now
Yes,
if you
sir.
choose instead of 00, if you choose 10, then you will find that it is choosing the entire bit of this one. Am I correct? So automatically this will come, this tag and this tag will be compared. If it is found, then it will be 1, not found 0. If it not found, then cache miss is called cache miss, and it will search the contents of the main memory. Do you get this point? Now, suppose today, I'm just opening the Miro again. So what we are doing here today is that another problem of this associate direct mapping is that only if I consider in context of main memory to cache memory, actually what is the purpose of the mapping actually? Can you tell me? Purpose of the mapping? If you see the purpose of the meeting, then you will find that our main purpose of the meeting that how a cache block, main memory block will go to the which location of the cache block. Is it clear? Is it clear or not clear? First tell me.
Yes.
Yes, sir, it
Yes,
is.
yes, sir.
So that is our criteria. That means from main memory to cache memory.
Yes.
Okay. Since we are dealing with the main memory to cache memory, so now you can point out one very important one, that how, that means I am telling that from main memory to cache memory. So it is many to one or one to one or one to many. I am telling that here is the main memory, suppose. So
Many
this is our This is our main memory. Okay. So in main memory, this is present. My is clearly visible, na?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
And this is the cache memory. Now our target date to map a main memory block to the cache. In direct mapping, you know that particular location will be shared. So here will be many location mapping to one location. So in direct mapping, we can say it is many to one, not one to many. In reverse, it's not possible because mapping takes place in this way. So we are writing many to one. This is clear?
Yes, sir.
So, so this is the context of the our direct memory locations point of view. Now, another approach we are getting that you will find that now what we are doing, suppose there is a m2 to the power m, that is the main memory block, and n number of, I am writing 2 to the power n. So this is the condition for, this is our main memory, and this is the Avantika. Are you
Yes,
there?
sir.
Ah,
Yes, sir.
question will come to you very soon. Prepare.
Okay, sir.
So then mn and bits are required to specify the address of the main and cache memory. Small n number of bits are required. In these cases, a small n number of bits are required for cache. So these are the two conditions we have studied so far. Okay. Now our point is that in case of main memory, we found that even if suppose we are accessing 0, 1, 2, 3, suppose in the cache line, this is the cache. Okay. And so yeah, I am writing again. If this is the cache, this is the cache, and this is the main memory. 64 location or 60 location, whatever may be, it will happen. 0, 1, 2, like in this way, suppose up to 16 is there, 15, that means 16 location. Now, our targets of the main memory deck, every time I found the 0 and 4, these are stored there. Even the pages are left blank. So there will be a conflict miss. Because we are accessing the source, those pages 0, 4, 8, then 12. So if I take these pages to the main memory to cache, every time page fault will occur. Because of the, they are sharing the same location. Same location. Even though there is a huge free spaces we can't occupy. So that is the, I think, drawback of what? DM, direct mapping. Is it clear this part? Drawback of direct mapping. Now what we are targeting that, how we can solve this problem, or you can say earlier it was maybe their problem and direct mapping solved. Direct mapping is that is very fast. This is clear, very fast. And suppose you are accessing like in this way, 0, 1, 2, 3. Then again you are accessing 0, 1, 2, 3. Maybe you are accessing 4, 5, 6, 7. If you access in this way, I think you will get the more benefit. Am I correct or wrong? I know my cache size of 4 will solve this purpose. 4 lines are there in the cache. They will solve this purpose. That is my clear point of view. And 4 pages I am simultaneously access like in this. So I think less number of conflict will happen instead of this if you are searching like in this way. Minimum cases. The least condition I'm telling, you will find more condition regarding this. Am I correct or not? If you are doing this type of 2 paper who have dedicated to simulation, this is the worst situation of the, I think in our cases in direct mapping. Now, in associate mapping, it is like in this way, since there is the n cache blocks and n texts are needed. That means main memory block can be mapped to any cache block. So if there is a main memory of m size 2 to the power m main memory blocks are there, and there is a 2 to the power n cache block, any block of main memory can place anywhere. So no line number is required. No line number is required. Seen in direct mapping, only particular destinations was allocated for particular page. So there is no place displacement policy. So in direct mapping, you just remember this in your mind, or you seal it in your mind. No page replacement policy is applicable. Am I correct this point? Avantika?
Yes, sir.
In direct mapping, I am writing no page replacement policy is applicable. Am I correct?
Yes, sir.
Why?
Because in there the main memory blocks can they can be mapped to only specific cache memory blocks, unlike in associative mapping.
Even the free spaces are there.
Yes, sir.
But in case of associative mapping,
They can be
anywhere,
mapped to any cache block.
anywhere where free space will be available. Okay, so it can start from searching from the very beginning. If it is available, it will allocate there. If it is not available, it will go to next, like in this way. If it is found that there is no pre-placement, randomly, particularly, any of the page is replaced. So here, which page will replace randomly, I can't say. Generally, this is the thing. That means anywhere a place, I found that the cache is full. Cache is full. Okay. Since cache is full, my target is that I have to replace a page. Which page I will replace? So that time list recently used. Only those pages I will replace which is not, that which I can say not used in this program frequently. That means list recently used pages can be replaced. Did you get the point? So in the associate mapping, you will find that page replacement policy will be required or is required. So I can say, since main memory block can be mapped to any cache block, the entire M bits. So entire, remember this, entire M bits of main memory block, that is main memory block address has to be used as tag. Is this same concept of direct mapping? No. In direct mapping, the M bits are divided into tag and line number. Am I correct? So in direct mapping, the tag size is very, very less comparing to the, is very less, very, very less. I can say it is less than the tag size in associative memory. So tag size in associative memory will be greater than tag size of direct memory. Can I write these things, Ochishman?
Sir, why would it be, sir? Could you repeat that, sir?
I mean, I am writing the question that in the main memory is M bit now completely converted to the tag of the cache line, because it can be located anywhere in the cache block. I am repeating this, say, since a main memory block can be mapped to any cache block, the entire M bits of the main memory block, this is the entire M bits of the main memory block address has to be used as a tag. Since there are n cache blocks, so n tags are needed. Total number of n equal to, I written that 2 to the power small n. Number of is n numbers of blocks are there, so n tags will be needed. These tags can be either stored in cache memory itself or separately stored in a associative memory called tag directory. I shown you some the concept tag directory earlier. So sometime it is stored in separately tag directory itself also. In the associated memory mapping scheme, when the CPU generates an address, the main memory block is extracted and usually the high order M bits and then associate compared with the N tag stored in the tag directory for a match. If a match occurs, the corresponding cache block number is retrieved and the cache is accessed for the required data. If the associative search fails, that means not matching with any of the tag of the cache memory, then the main memory is accessed for the required data, and this is cache miss, you know. So a block of data is transferred to the cache and the tag directory is updated accordingly. So enter block from the main memory to cache memory, you have to fetch. And then tag will be updated. If there is no free space in the cache, then that is the target that the incoming main memory block will replace an existing cache block. And that time you have to apply some replacement policy, just like LRO, maybe FIFO, maybe LFO, anything, but mostly in the cache LRO used. So we will follow by default the concept of LRO. Can you tell me the advantage of this one? Any advantage of such process? Can you tell me advantage of any such process? Karam?
Hello.
Yes,
sir.
you are
I'm
audible.
Yes, sir. Yes, sir.
I am telling the any advantage of such methods?
Associative, sir. In associative, conflict misses will be less.
Conflict misses will be less. Very, very good point. Anything?
And if in direct mapping, if there was an empty line in the cache, if we got a memory block, then we can't put it in there if the modulo is not matching. But here we can fill the cache even if there is some space.
I'm not clear this point. Can you elaborate it again little bit?
Sir, like in direct mapping, the block
Yes.
B0 can only go into line number 1 of.
Suppose. Okay.
But if we again get B4, then we have to add it in line 1 only, even if line 2, 3, 4 are empty.
And this is the conflict misses, the story of conflict misses you're telling.
Yes.
But in context of hardware perspectives of view, any advantage you get? Or maybe, sorry, not hardware also, I mean even more flexibility, that in context of you suppose that you are thinking that whenever any mapping idea will come, I have to divide in cache and line number. Am I correct or wrong?
Sir, the tag, sir, in case of associative addressing, sir, in that case, since the tag is larger, sir, there is no need to make those divisions.
Then it will may give an advantage.
Yes, sir, it will give advantage in the sense that it's more detailed. Like it's less like it's more specific for the associative mapping to happen faster rather.
Clear nahi aa raha hai. Actually, since there is no breaking of the main memory address, in direct mapping, whenever a main memory block load into the cache, you have to, from the M bits, you have to segregate the line number and also tag. Only based on the line number, then you go to the cache memory to store it that location, and tag directory will be updated. Okay. And for that purpose, was address translation mechanism should work there, because your M bit will be now segregated to line number as well as tag bit. But in case of associate memory, that is not required. Directly your M bits of the main memory will be directly added as a tag bit. Am I clear or not clear?
Yes,
Is it
sir.
clear? So these principal advantages of this method are is that great flexibility of the associate mapping is that great. I have a great flexibility that address translation process can be performed quickly because of the high speed tag directory. Tag directory is higher than the cache directory also, high speed. And since here entire tag directory will be only searched for the data, if the tag directory I found the data, it look like in this way. Suppose it is a cache memory, it is the main memory, it is the cache memory, it is the main memory, and some tag directory is updated, is the tag directory. And tag directories contain only those pages which is present on the caches. And it is very faster than this one. It is another associate memory. Not mapping, I'm telling the associate memory, you can say. helpful for this purpose. So what happened that whenever CPU generates the address, it will directly go to the tag directory and it is very faster. It's very faster. If it is give signal 1 automatically particular for tag, it will read the data. Because at least in the cache present, I found it. Otherwise, you can say the address translation process from the main memory, whenever you have to shift a process, get the free space, and from the top to bottom when it is go get the free space, allocate the block there, and corresponding tag, you just update the tag directive. But that's sufficient. So the address translation process is quickly because no further breaking of M bit of the main memory to tag and line number, that is not required in these cases. So this point, am I clear to all of you? So, but however, the high cost associated with the tag directory limits the liver implementation of the data. That means here it is found that main memory address is interpreted as the tagged word to directly tag and only word. Tag uniquely identifies the block. Every line's tag is examined for the match. This is the very important point. Every line's tag is examined for match. So I can say if tag are associated with the cache, so parallelly each of the tag is parallel compared. So here how many tag comparison required? One comparator or multiple comparator? That is first tell me.
Multiple for parallel.
Multiple comparator. Point to be noted. There are multiple comparator required. So I'll come to the point later. That's why cache search gets expensive. Comparing earlier, it's become very expensive. Is it clear this point? So here the samples I have given. Individually, the dot 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 I have given to understand that for the each of the tag will be now compared. So there is the compare circuit, and each time each of the tag will be compared, and finally I have to find out the my system. So if I go a little bit Miro, I can draw the figures again. So it looks like in this in context of hardware view. If you go to the hardware view, how does it look? That's I'm
visible, sir.
yes, I'm coming. Now it's visible, I think. Okay. If you go to the hardware point of view, you will find that from the main memory, that is the block number, or you can say M bit block number, and the block offset. This is the BO. Okay. And here in the cache memory, I consider the tag directory itself in the cache. So here all the tags are compared. So all the tags are parallelly goes to the compare circuit, each of them compare, and then each of the output will be direct to the in a OR gate. Are you getting my point? If any one is 1, what does it mean the output? 1. So that means it is present in the cache, anywhere in the cache. I don't know where. But I understand that where it is present. In direct mapping, you can directly identify, yes, it is present, and in this location it is present. But in this case, I can't guess where it is present because anyone can generate one. So I have to ensure that yes, it is present on the caches. It is suppose compare. It is also compare. It is compare. It is compare. It is called compare. So anywhere in the cache, it is available. That only we can ensure. And after that, again go to the cache memory and find it out. Is it clear this point? So again, I am coming to the point in my slides that you will find particularly in the associated mapping, if I consider associated mapping, then you'll find that in associated mapping that comparison become expensive, as well as also in individual tag, all the tags are compared. After searching all the cache, again becomes cache search also become expensive. If I consider tag is a separate directory also. Initially I have to compare the tag. If it is found, then again I have to search the cache location where it is present. So like in this way, it's become very high. Here you have checked that only S bit directly is converted to the tag. Okay, block offset is the O. Now tag is directly the main memory address. Okay, so this is the one thing in associated memory. So advantage, flexibility. It is a flexible, and also such a flexible that address translation mechanism become very quickly because of the high-speed tag directory, as well as the since entire tag is converted to the entire main memory now block bits, M bits is converted to the tag bits. And also utilizing the cache, because due to the conflict misses, sometimes we found that spaces are there, but we can't utilize it. There is a chance to utilize it. But disadvantage, fully associated memory is a fully disadvantage that require test search and that is parallel associative searching is also required. Hardware cost is very high. Might require extra hardware you need to do the searches for searching mechanism. Require a replacement policy also when KLRV or LRV policy also required. So it's become get expensive. Is it clear? So what should be our opinion? I already compared these two methods. Only fully associative. If I make the searches fully associative, then I will get the most advantage flexibility and utilizing the cache. But in the other side, in direct mapping, hardware cost is very less, comparatively very faster than associative, but conflict misses occurs as well as the space is not utilized. Utilizing the cache is very poor in the DM. Utilizing the cache is very high in associative. So what should I do? Any idea from your side? Any trade-off? Any idea of trade-off? Barnali?
Yes, sir.
Any idea what can I do? Because I found both the processes some advantage and disadvantages. In DM, there is a less utilization of the cache, but it is very fast and less expensive. Hardware cost is very less. But in case of that one, which is I called our that method, in associative, cache utilization is very high. But again, on the other side, it be a flexibility also high, and on the other side, it is very expensive. Place replacement policy, everything is required. So, what should be the trade-off that we can get benefit of this to both the two? Can you think of that matter?
So, direct mapping for large bulks of data,
And
cache for and associative mapping for like small amounts.
but that cannot be done because hardware once configured and organized properly, that cannot be done during the program. Nah?
Yes, sir.
Either I have to go associative, either I have to go DM.
So in that case, DM sounds more economical because it's giving faster and we don't need additional hardware or
But suppose you are using some game, you are working in railway reservation system, or you are using some monopoly tag where the pages are referenced, particular to two pages are referenced multiple times of the DM behaviors. Suppose 040404. Same location, two pages are accessing and you are continuously accessing like in this way. Then
So our objective is mainly lower miss rates and higher costs, right?
I would like to reduce the cost. Also, I would like to get the flexibility of the associative. That means my intention that I would like to trade off between these two. Then my trade-off view should be, I think these 2 points. One is speed.
Sir, you can divide the cache into certain line blocks.
Yes.
Those line blocks will behave as fully associative, but there will be some property of direct mapping, like
Okay, so that you are telling set associative mapping. Yes. So you are telling that set associative memory, and that is used in our modern days computer. Okay, that means I will divide the cache into multiple sets, and within the sets they will behave as a associative. But to search a particular set, we will go for the that means associativity set. That means I will break suppose 2 or 4 cache block into one set, and within the set they are associative. Anywhere I can store. It means that whenever I will search, my set is just like my line number. Directly I will go that particular line or set, and after going to the set, if I found this is occupied, then I will go this. Or if it is occupied, then I'll go this. If it is occupied, then I'll go this. If all are occupied, I will apply the LRE policy. So within the set, at least I can do my associativity, so more flexibility. But also particular sets, we can go for searching like DMing. So entire other multiple case searches is not required. So that is the more economical, more faster, and more the trade-off, I can say, trade-off the earlier two policy. The flexibility is that within the set more flexible, cache utilization will be high, but within and also to be particular definite location of particular set, searching will be like a memory. So set associative mapping helps reduce the complexity of the mapping matching harder of an associative map cache. Cache is divided into number of sets and each set contains number of lines. The two-way associative case, 2 lines per set. If I say 4-way, then 4 lines per set. If I say k-way, then k set, that means lines per set. K lines per set. That is called k-way associative, k lines per set. Is it clear? A block of memory is restricted to now particular specific set. A block of main memory map to any line in the given set. Within the set, any line. So associativity prevails there. So cache is divided into number of sets. Each set contains number of lines. A given block maps to any line within a given set, within the particular given set. So 2 lines per set, I will say 2A associated 2A. If 3 lines per set, I will say the 3 associative memory. So that is the advantage of associative memory. That means now you will find that in associative memory, I will use some multiplexer to choose particular set again. Am I correct? I will choose the multiplexer, but within the set, I will use comparator. Okay. It means that the number of comparator at a time will use very less. Even I know for each of block associated there will be a comparator because maybe 16 blocks, 16 comparators are there for 16 tags. But at a time only if I use 2 blocks per time, so 2 comparator will be active. So huge reduction of the speed. Is this point is clear? Is this point is clear?
Yes, sir.
Okay, so block can reside in one few frames groups called sets. Each frame is called a way, and this is the 2 associative memories examples I have given. So up to this we found that now see each of these blocks are mapped to the particular sets, and now here address mechanism little bit differ. Then there also tag. Now instead of set a line, it will be set, and there will be the total block of set. So here conversion become tag and set. But to get the set, it is not directly just line number, because within the set you have a line that is total cache line. Suppose I have a 16 cache lines, total cache line, and if I make if I make 4 set, so 16 by 4 means 4 means how much? 2 to the power 2. So 2 bit will be the tag. 2 bit required for choose any tag, and within the tag 4 blocks are there. Is it clear? This for 4 lines are there within the tags for use bit. Is this point is clear?
Sir,
or
could
not
you
clear?
explain it once again, sir?
Again, I am repeating. Okay. So as Milo. I am telling that now it is my main memory address M bits, and this is the block offset. Now in associated, M is directly M bit tag. It is associative memory. In direct memory, M bit is segregated to tag and line number. And you know is line number, if for a particular cache there is a 4 lines are there, so 4 lines can be chosen using 2 bit. Any 2 bit 0001 1011. So that 2, because 4 lines are there, to the power 2 bit. So that time 2 bit is sufficient for the line number detection. Rest of the bit is tag. Rest bit is tag. Now in scatter strip, now these 2 become one set 0, and these become set 1, 2 set. Now 2 sets, I think 0 or 1, any 1 bit is sufficient. If 0, this will be selected. If 1, any 1 set. So that time you have become tag bit and 1 bit for set, and this is the block of set. In earlier cases in direct memory, 2 bit for the cache and tag, and there's the set block BO. Now 2 bit and there is bigger 1 bit. So when you are mapping direct to set as memory, that size, because this size is fixed. This is total what? M. This is total what? M. But now the tag bit would increase or decrease comparing DM?
It will increase.
It will increase what? In DM or tag? Tag bit will set, it is decrease or increase? When I convert DM to set?
In set it will increase.
Yes. When you go DM to tag memory, that time tag memory size. Well, this is the fix, because I know tag plus line number equal to M bits. Here also tag plus set number equal to also M bits. But since lines are now collapsed into number of sets, so it become less number of bit. There is a chance. So less number bit, and due to this less number, automatically tag size will increase, because this is the fixed M bits are there. So that is the one thing I would like to share with you all. Is it clear at this point?
Yes, sir.
Okay. So it becomes like in this way. If I write totally like in this way, this is suppose M bits are there. Now mathematics portion will come very soon. So listen with rapt attention. M bits are there. Then I can say, and if there is a cache size is n, the cache size bits is if I consider n bit for cache, because total location is 2 to the power n, so n bit for cache line. So what will be the tag size that time? What is the tag size and what is the set size? Cache block number, if I can say. This is the for tag and this is the cache. So if there is a sets are there, so I can say if I am using as a tag n caches there, so n if number of s are there for, because I have a suppose 4 lines. Okay, so I have a 4 lines, that means n is how much? 2. Am I correct? N is 2. Okay. Now you are making S 2 bits and 2 bits, 2-way set. That time, how many bits are required for set? 1 bit, because 2 and 2, 4 lines are there. So 2 set is sufficient. 4 lines are there. And you are making 2-way. So these 2 will be 1 set and these 2 will be another set. And this among these 2, either 0 or 1 I can record set. So 1 bit is required. So in this case, if you minus 2 minus 1, automatically what? S bit equal to 1. So that's why I am telling that it is I am writing n minus s, and this is the n minus n plus s, that is tag bit. Now it is increasing or not? It is increasing. In direct memory, tag is directly m minus the n. Is it clear?
Yes, sir.
In direct memory, that is m minus n. Here, due to the plus s, I can say tag will increase. So can you justify this point by numerically also? You can say, yes, this is possible for this issue. Okay. So at least I can say there's a few points you can mention in these cases, that the reduction will significant if the processor frequently requires information from 2 main memory blocks that are multiples of n blocks away from one another. According to the locality of reference principle, such reference sequences are unlikely, and thus the direct mapping techniques may not produce disastrous result all the time if we do now with set associative way. It is also combination of direct mapping as well as associative. Direct mapping for searching to the particular set, and within the set to get the block, that is associative. So flexibility, get the block and store the block, both storing and retrieving is the associative becomes very flexible, because to storing any free location, it will be very easy to me, or find out anywhere it can be stayed. It will be very free for me. The address translation become very easy within the set, and searching also very become because due to the presence of particular set. Okay, so let's try one mathematics. You write, I am giving some data and tell me the answer. Suppose my main memory is 8K. Okay, this is my main memory size, that is 8K, and N, the cache size I am writing 512, that is byte you can consider. And block size, it is very important parameter. Block size is 8 byte, also byte, is a KB. Okay, then you can tell me the in case of main memory block, in case of indirect mapping, fully associative mapping, and shared associative mapping, tell me the structure you make me the address translation mechanism. I can say here, since 8 bytes are there, block size there means 2 to the power 3. So here 3 bit is required. Main memory is 8 KB. 8 KB means what? 2 to the power 13. Can I write it?
13 bytes.
So
13
13.
bits.
Yes.
So main memory will be 13 bits, sir.
13. So total size of the address was 16.
16.
Is it clear? 16 bit. Am I clear this point? Now you tell me that is my block number and that is my block offset, or you can say you also scale a word. Okay, block word block. Now if I convert in DM, how does it looks? Tell me, and how number of bits will be there. Solve it and tell me.
Sir, repeat the last part once again, sir. I missed out on the connection.
I told that if I now convert this problem, this is the my actual CPU generated address from
Yes.
from your hardware. I came to know whatever hardware you have. I came to know this is the things. Now,
Yes.
if I convert in direct mapping, then the block number, line number, offset. So there will be some bit address translation. So
Yes.
address mapping. So I need that bit information of the address.
Okay, sir. Okay, sir. Sir, N is cache size, na? N equal to 512 bytes is the cache size.
Cache size n equal to 512. Sorry, 512 byte. 512 byte means how much? 2 to the power?
Sir, 9.
9. So you found 9 bit.
9 bit.
This is the 9 bit. This is the 13 bit. And here also 3 bit for block offset. So first condition, if I make it direct mapping, suppose. In direct mapping, what are the 3 fields?
So it will be 9. So it will be cache will be 9 bits. The block
That is the tag, this is the line number, and this is the block offset. Or you can say word W. Okay. I think block offset is always fixed.
Yes, sir.
3
So
bit.
it's 3 bits.
And total address is how much? 16 bit. That is also
16.
fixed. That is
The
also
tag will be
fixed.
4, sir.
Tag will be
4.
4. Okay. And rest will be
9.
9 is automatically clear. Now Avantika.
Yes, sir.
Tell me, in fully associative, what will be the condition?
Sir, in fully associative mapping, the whole main memory will be the tag size. So
Very
13
good.
13
13
bit.
bit. Yes, very good. That is 13 bit and
And
block
the block offset is 3 bit.
3 bit. Very good. I am very happy. At least another girls I found. Next Lakshmi Bai. After Bonali Shankita, I found Avantika. Any other? Abha? आभा को बुला बुला के ना मेरा गला खराब हो जाता है. आभा कहाँ रहता है मुझे मालूम नहीं.
Yes, sir.
अरे बापा, कहाँ से आए? बहुत दूर रहते हैं क्या?
नहीं सर.
कहाँ रहते हो आभा, बोलो.
कोलकाता में.
चांद पर.
अच्छा, चांद पे. कौन बोला? कौन बोला? ये दुष्ट कौन है? ये दुष्ट कौन है? अच्छा, आनंद कॉलेज में. Anshika, Ankita, Ankita, Abha. 3 friends. Okay.
Yes, sir.
So these 3 friends tell me if I make कितना दे 4-way set associative, suppose 4-way set associative, then tell me the condition. Also not 4-way, you can say size of the tag bit, if I consider okay, if I take 4-way associative, that means 4 blocks per set. Can I say or not? If I consider 4 block per set, anyone?
583, sir.
I consider that suppose 16 set associative, 16-way set associative. Only show Ankita and Abha and another girl. What's the name of the girl?
Anshika.
Anshika. You 3 people tell me what will happen. There will be 3 field, na? One is tag. Am I correct? Another is the set, and this is words or block of set. Now tell me, because this is fixed, CPU address generator is 16-bit. This is fixed. Now you tell me.
Sir, tag bit is 9.
Tag bit is 9. Okay. You just tell I am writing. Then set
4.
4. Okay, then word
3.
3. That is no problem. I think this is always same. The concept of this part becomes some illusion. I told the 16-way set associative. That means within the set, 16 blocks will be there. Am I correct or wrong?
Yes, sir.
Sir, 2 bit
This
set.
is one per set, right?
Yes.
Yes, sir. So if it's 16-way in a 16-bit set, in a 16-bit main memory, sir, then it's one line per set. So in that case, wouldn't it be 0 lines for the set region?
What is the how many? What is the total number of lines are there? 2 to the power 9. 2 to the power 9 lines are there. Am I
Okay.
correct? How many
Okay.
lines are there?
2 to the power 5. So in that, so 2 to the power 9. Okay, tag, acha.
Tag not. I am telling you how many lines are there. If you have a line number 9, so can I say or not? 2 to the power 9 numbers or lines are there? Total lines?
Yes, sir. Yes.
Yes, sir.
That now 16 way. That means per I will make 16 means 2 to the power 4.
Yes, sir.
I told na 16 way.
Yes, sir. So 2 to the power 5. So 5.
16 means
5
16.
set lines.
16 means what? 2 to the power 4. That means 2 to the power 5. So what is the set bit?
5.
5,
5. Then what will be the tag bit?
8,
Automatically 8. In direct memory, what is the tag bit?
4.
In direct memory, what is the tag bit?
4, sir.
4.
4. And what is the tag bit?
8.
So see, it is increases. Is it clear?
Yes, sir.
Is this problem is solved?
yes, sir.
Solved. Okay. So let's go to the another chapters. Another mathematics. Suppose this problem. Okay. Here there will be, if I consider associative memory, in associative memory entire bit will be tag. So can you tell me what will the answer of this question here? Anyone?
So this is a full associative mapping.
Associate mapping.
17.
17.
17.
Yes.
Tell me how.
Yes, sir.
70.
17 how?
Main memory size is 7.
Yes, sir.
So
Sir, main-
128 KB 2 to the power 17.
Very good. And tag directory. Tag directory. Tag directory.
Sir, 17 into 2 to the power 6.
17 into 2 to the power
6, sir.
2 to the power 6.
6.
How did you find out 2 to the power 6?
Sir, total number of lines.
Total number of
Lines.
How did you find out total number of lines?
Sir, cache size by block size.
Cache size was 16 KB. Block size was 256. So 2 to the power 250 to the power 8 na 256. And here 2 to the power how much?
18, sir. 14.
16 4 plus 10 14. So it is gone 2 to the power 6. That's why number of lines becomes 2 to the power 16, 2 to the power 6. So this is the tag directory size. Is it clear to all of you? Or any doubts? Exam में तो maths करना होगा भाई. Even though in the online exam one is doing mathematics, other will automatically see and give the exam, you will pass. In the passing exam does not matter. But what will happen in future? When this type of problem you have to solve during the examinations or during your competitive results or something else in future, that time you will find that you are unable to solve, and that time it will become very, it is in software engineering concept. As a famous proverb is there. If you unable to find out, that is a famous poem. If you unable to find a bug, B-U-G, bug. Anyone know Bengali? I don't know actually Hindi. It is writing Hindi, it is a bug. Can I say it is bug? हिंदी में इसको क्या कहोगे तुम? हिंदी में क्या लिखा मेरे समझ में आ रहा है?
बाघ.
बाघ. ठीक है. So हिंदी में बाघ है तो इस बाघ को बंगाली में भी BUG को स्पेलिंग बाघ बोलते हैं. ठीक है. If you are unable to find a bug at early stage, that means अभी आप लोगों को पढ़ रहा हो ना, तो अभी अगर पढ़ लोगे आराम से सीख जाएंगे. नहीं तो फ्यूचर में क्या हो जाएंगे? BAGH. ओके, दैट टाइम ये हो जाएंगे. ये क्या है?
बाघ. सर बाघ. टाइगर.
বেঙ্গলি মে আমি একটু বাংলাও কম লিখতে পারি না, বুঝে বাঙালি বুঝতে পারছো?
हाँ सर.
हाँ, भाग. उड़िया में कहते हैं उसको भागो. ठीक है. तो अभी सॉल्व कर लो, नहीं तो फ्यूचर में ये आएंगे आपके सामने. अभी छोटा है कि डेमो का फिगर होता ना, बाघ का सिंबल तो ये है ना, ये होते बाघ का सिंबल. तो बाघ का भी पकड़ लो, नहीं तो ये यहाँ पे आ जाएंगे. आप लोग तो प्लान करके सोचा है ना ऑनलाइन एग्जाम होगा, देख देख के मार देंगे. और विभासन सर तो ही हम लोग को परेशानी देने के लिए. ठीक है. बट आज का परेशानी, कल का टेंशन रिमूव हो जाएंगे. ठीक है. फिर भी आप लोग नहीं पढ़ेंगे मुझे मालूम है, बट दैट इज अप टू योर डिसीजन. व्हाट एवर आई फाइंड माई सुटेबिलिटी आई हैव शोन. So my point is that you people try to at least try to understand whatever I am showing you, because all these things are very important for your future. Though you people are not giving full concentration, you will get the problem in your future. ये स्टोरी फेमस स्टोरी आपको मालूम था दोस्त? ये हम लोग का सॉफ्टवेयर इंजीनियरिंग इंडस्ट्री में पहले सिखाता है, बाग आना है या बाग खाना है। तो अभी सोच के चलो तुम लोगों को क्या चाहिए। जनरली तुम लोगों को तो सिर्फ ऑनलाइन एग्जाम चाहिए, सही है ना, जब तक बीटेक रहेगा।
नहीं सर, ऐसा नहीं है, कॉलेज जाने का मन है।
कॉलेज जाने का मन है, बट एग्जाम फिर ऑनलाइन ही हो। अच्छा ठीक है, तो सेम प्रॉब्लम अभी सॉल्व करेंगे। किसी को तो देना होगा। ईशान, ईशान।
यस सर।
हाँ हो क्या बाबा, बोलना है सर, नहीं तो मुझे समझ में नहीं आता। ठीक है, तो मान लो अभी इसको अगर मैं क्या बोलते हैं सेट एसोसिएटिव मेमोरी में कन्वर्ट करना चाहता हूँ। ठीक है, इफ आई गिव द कॉन्सेप्ट लाइक सेट साइज 2 ब्लॉक 2A सेट एसोसिएटिव। ओके,
सर आर यू राइटिंग समथिंग? कुछ दिख नहीं रहा।
क्या दिख रहा है यहाँ?
सर सिर्फ स्क्रीन दिख रहा है आपका। आपने कुछ अभी लिखा है क्या रिसेंटली?
नहीं, मैंने कुछ नहीं लिखा।
हाँ ठीक है।
ये दिखाई दे रहा है अभी आपको?
हाँ सर अभी दिखाई दे रहा
अच्छा, तो यहाँ पे तो ये प्रॉब्लम दिया है ना।
है। यस सर।
Now, if I would like to make is a 2A shared associative memory. Okay, that means I would like to map 2A set associative. Can you tell me what is 2A set associative meaning? Is what does it mean? 2A set associative meaning?
Two sets, sir.
Two sets or two lines per set.
Yes, sir.
Which
Two
one?
sets.
2 lines per set.
Two
Yes.
sets.
2 lines per set sir.
2 lines per
Per
set. Okay, then tell me the tag and tag date. Ishan will answer.
Okay sir, I'm calculating.
Okay, okay. In the meantime, when Ishan is calculating, I am calling.
Question, sir. Sir, I had a question, sir.
Bolo.
Sir, when we did the first problem, sir, were we doing it with just associative, or were we doing it with the direct mapping technique, sir?
Which one? Anywhere, whatever same data is available, you can apply direct mapping, you can apply set associative,
No, sir,
you can
first-
apply.
Sir, the first time, like the first sum that we solved, sir, the 128 KB, 16 KB, with 70, sir, we were assuming it was direct mapping over there.
No, now you have to assume associative.
But before we were assuming direct mapping, right?
Yeah. Earlier, this same problem I have solved using direct mapping concept also. That time tag bit and tag date will differ. Suppose this RAM size is there, cache size is there, block size is there, and you have to make in direct mapping way, then what will be the tag and tag date size? If you make in a set associative, what is the set? Just as a simple way to solve it. That's I'm telling.
Okay, sir.
Is it clear?
Yes, sir, clear, sir.
So in direct mapping, no choice of replacement. So each block only maps to one line. ईशान करते रहना और मुझे आंसर बोलना.
Okay sir.
Okay. So each block only maps to one line and replace that line. So remember this point, very important, no choice. Since no choice, no replacement algorithm. I am telling multiple times, even though you people will in the final year bye, if I ask, can I apply LRU on direct mapping? Answer is yes, sir. How will apply? Then they start explaining LRU. And nicely, efficiently, correctly, they are explaining LRU. Is it the correct answer? If I ask a student in direct mapping policy, how do you will apply LRU? Then can it apply? He told the answer is yes, sir, it is possible. Then how it is possible? Then he explained the answer. So when he is not selected, then he will argue with me, sir, I have given the answer correct properly, even from like a exact copy of the book, but you are not accepting my answer. Then what will be my answer? Rajata?
Sir? So I was doing the sum, sir. I was not listening, so I thought you were repeating
Oh,
something.
I told that in final year I asked a student, in direct mapping scheme, I would like to apply LRU. How do I apply? He explained everything of the LRU nicely, properly, and even I have not given him mark. Is it correct or wrong?
So there is no replacement algorithm for direct mapping. No,
But
so
he
how?
applied properly, direct mapping applied on. What should be his answer actually?
So no replacement algorithm. So no
No
LRU.
replacement, sir. Even I give multiple trap to you, but your answer should be always concise. That it is not, sir, possible. But he multiple time iterated with me, sir. It is possible, and this way we can solve it. So that's happened in my life also. Okay. Now it is now. I think today's discussion is clear from direct mapping. In associative algorithm must implemented in hardware. Is a very speed. Least recently algorithm is follows. Today I will start to solve for 5 minutes if possible LRU, and then we'll go for the FIFO. Now come to the point. In the right policy must in during I think I have explained the right policy. Right policy must not overwrite a cache block unless main memory is up to date. Okay. Multiple CPUs may have individual caches and that time may is a big issue. Input output may address main memory directly. So let's say in write throw policy, all writes go to main memory as well in the cache. So that's why write through. How to remember this part? That is the CM and that is the AMM. Through means through. Just like you fire the arrow and turn the arrow. So through both are simultaneously updated. That's why write through. Can you remember this thing? Cache and main memory are updated simultaneously. Multiple CPU can monitor main memory traffic to keep local cache up to date. So in multiple environment in write through, how does it work? They have some monitor main memory. Until it changes, they have to regard over. Lots of traffic will happen. Slow down in the writes. Remember, sometimes write through caches it is bogus. So it is better we will write once and update the once. That's why write back updates initially made in cache only. So remember this point. Dirty bit is set when we write on the cache. So there is a bit, access line number, cache, tag, line number, block offset. There is another bit that I have not mentioned. It is not associated with the mapping. It is associated with the writing or updating policy. So during the calculation, you may add extra bit required for the hardware that is called dirty bit for cache slot is declared when update occurs. It means that if dirty bit is 1, I can say the cache data is updated. When I'll replace it, I will check the dirty bit. If it is 1, so some writing happened. If it is 0, no writing happened, directly deleted. If it is 1, then main memory also updated. Is this point is clear? If cache line is to be replaced, write the existing cache line to main memory if dirty bit is set. Dirty bit set means 1, loading a new main memory block. So am I correct this point? These two policies can be applied to the write back during the replacement when you're writing. Which one is suitable for us, write back or write through?
Right back.
Write back policy. Okay. And also in multiple, the question may be asked to you when you are doing multiple processor environment, then how do you implement the write back policy? You can say that in multiple CPU will check, monitor the main memory only, and that main memory he will find only once is updated. If even cache is read multiple times also, the dirty bit say always remains 0, so no updation will occur. Only when the page is replacing and dirty bit is still 0, then main memory will not be updated because the cache content is only read. It is not updated or not right. So that time even dirty bit is 0, so write back policy also ensure that no further writing is required. So only once time you will write, multiple time writing is not required. And in multiple cache environment also it can be solved easily. So huge that means traffic we can avoid. So we can use unified or split caches also. That means one cache for data and an instruction, or one for data and one for instruction. Generally in embedded system, the split caches concepts are used, but whatever we have still now all are only unified. Unified contains the high hit rate because every time in the cache data will find balanced load and of instruction and data fetch, only one cache to design and implement. So designing implement one cache is very easy. I am not telling multiple caches or multi-level caches. It is split or multiple caches based on the characteristic of the instruction data where I will store. But the advantage of split caches eliminates cache contention between instruction, fetch and decode, unit and execution error. Is important in pipelining. The split caches will help us. Sometimes in pipelining when you are executing some data, so that time you can do only data cache where from the second instruction you can use the second instruction can be fetched from the instruction cache if you have separately. So conflict or data bandwidth will can minimize it here. Bandwidth utilizes or wastage can be prevented. So that is the advantage of this one. Okay. Can you solve this question, the answer? A computer has 256 kilobyte 4-way set associated. The question is clear to you? Is the question is visible to you?
Sir, it's visible, sir.
Okay.
Yes, sir.
Yes. See, 4-way set associative write-back data cache. Remember write-back data cache with block size 32 bytes. So you people can solve, I think, easily without my help also, even though for the first problems I am writing. Computers 256 bytes. Remember this one. The processor sends 32-bit address. What is the size of the processors? 32-bit address. That means the CPU generated the address size 30-bit to cache. Total size is 32-bit. Each cache tag directory entry contains, in addition, see in the tag directory, in addition to address tag, 2 valid bit, 2 bit for valid, 1 plus 1 for modified bit and 1 for replacement bit. So they are giving 4 additional bit you have to add. You have to add 4 additional bit. The numbers of bit in the tag field of an address is a 4-way associative. Okay. And 256 KB data cache, na? 256 KB data cache. What is it in data cache?
Sir, it's answer 16.
I have to check. I don't know. Answer
The
is?
tag is coming to be 16.
Okay. Answer is 16. Very good. Who has answered? Who
Sir,
answered? I have not seen. Huh?
Sir,
Okay,
Sankita.
Shankita. Okay, very good. So answer is coming 16. Can you explain, Shankita, how did you get it?
Yes, sir. The number of blocks is the cache size by the block size, which is 256 by 2 to the power by 32, which is coming to be 2 to the power 13, like 2 to the power 10 plus 2 to the, into 2 to the power 3. So it's coming to the power 13, and the number of sets is 2 to the power 13 by 4. That is 2 to the power 11. So tag set plus.
That means first of all 2 to the power 2 to the power 256 means 2 to the power 18, na?
Yes, sir.
2 to the power 18 divided by
18 divided by 2 to the power 5.
2 to
So
the
2 to the
power
power
5.
13.
So it is 2 to the power 13. That is the total number of blocks.
Yes,
And
sir.
now
So we'll
total
find out
number of
the
blocks
sets.
by per set. That means what is the set size? 4. 2 to the power
Yes, sir.
2. Then it is coming how much? 2 to the power
11.
11. Very good. So 11 becomes the, it is
Number of sets.
okay. I have not mentioned data cache, block size, the processors. Okay, research associative. So set size is how much? 11, na?
Yes, sir. To the power 11.
11. And this size is 5 bit. That is block offset.
Yes,
5.
sir. Back
Okay.
set is 5.
Now 5 plus 11, how much? 16. Am I correct or wrong?
Yes, sir. Yes, sir. The total is 32. So 32 minus 16, that comes out to be, the tag is 16.
16. Okay. In addition to remaining 4 more bits. Okay. So tag size become actually 16. Now
Yes, sir.
here I have given some question and their answer I have solved. So can you solve this question, this question? This is the last of this class today. This one. My question is this one. The size of the physical address space of the processor is 2p bytes. Okay, that means p bits. Am I clear? Main memory address p. Word length w. So total is p plus w. The capacity of the cache memory is 2n bytes, 2 to the power n. Now the size of the each cache blocks is 2 to the power m words. For a KOA set associative cache memory, the length of the tag field. How much? Tell me.
Sir, in that case, P plus W is the total size of the set, sir. And since capacity of cache memory is n bytes, it will be P plus W by n. Like P plus W minus n will be the number of
P plus W minus
n.
n or KOA set associative there.
Yes, sir. So that will be again minus n minus k because k is set.
Then what is the tag field?
Sir, in that case, the number of bits in the tag field will be size of each cache block is 2 to the power m words.
Answer is B. P minus n plus log 2k. You solve it and try to get it finally. Two to the power capital M and 2 to the power W. Is there any difference? Each of them word is word length 2W and cache block is 2 to the power M words. That means during the tag field computation, why P plus W you will consider? Only the M bits P, M, P will be distributed to the tag and set. Am I correct or wrong? What is the concept I given? To set the fine number, go to the Miro. You forgot. If you remember, I think I have told her one thing. What is the text size? In direct cases, M minus N plus S. Did you get my point?
Yes,
Here,
sir.
what is M? M is given P. P minus N. N is also given capital N. P minus N plus log 2k. Because S will be converted to the number of cache line. Here is given S. So 2S at it will be divided by log 2k. Are you getting my point or not? So automatically there the KOA set associative. So the number of sets will be log 2k or not?
Yes, sir.
Not,
Yes, sir.
not too clear or not clear? Tell me. Nothing
Yes.
you have to worry about in other parts of the concepts. Okay. So I am stopping the classes here.